Okay, welcome to the next stop on the Grand Canyon North Rim field trip. We're going to be stopping at 3 locations: the Walhalla Viewpoint, Cape Royal, and Cape Final. These are some of these spots offer some of the most spectacular views in all of the Grand Canyon area. We're going to see some new Grand Canyon supergroup rocks, some we haven't seen before. Look at an interesting feature, the Uncar Delta, where the flow of a side stream significantly influences the course of the Colorado River. Take a look at the Great Unconformity, where it's exposed in the eastern part of the park. It's pretty interesting. Take a look at the Paleozoic sequence of rocks, and another nice view of the Chuar Syncline. So these locations are on a road that drives out this peninsula. The Cape Final is here, Cape Royal is approximately there, and the Walhalla Viewpoint is there. So let's zoom in on a box about this big and take a look in a little bit more detail. So here we are again in satellite view. Here is the Walhalla overlook point. Cape Royal is here, and Cape Final is here. So we're going to be looking at stuff towards the east, or generally towards the southeast. So the thing I'd like you to notice is the difference in rock color here, which you can very clearly see in satellite view. All of this stuff is a nice red, dark red color in here, or even sometimes black here. The red stuff is one of the units of these Grand Canyon supergroup rocks. It is the Dox Formation. And the black stuff is a layer of lava, basalt lava, which lies on the top of it. And we're going to see some detailed images of that here shortly. So compare these red rocks, this stuff here, compared to the brown and the whites and the greens over here, or the browns and the whites and the greens over here. Okay, these on this side, or close to our viewpoints over on this side, are the Paleozoic rocks. There's quite a distinct difference in color, as you'll see again when we take a look. So let's look at the geologic map. Again, Cape Royal, Cape Final, and the Walhalla Viewpoint is approximately there. And we're going to be looking from these viewpoints towards the southeast or towards the east. The geologic map in this area is fairly complicated. That's for two reasons. As you can see, there's quite a bit of something going on in this area, and it's complicated for two reasons. One is there are a number of different rocks exposed here, some of them tilted, some of them flat, but the big reason is that the topography, the shape of the surface of the canyon, is quite complicated here too. So that influences the types of rocks you see at the surface, and in this case makes the geologic map fairly complicated and interesting. So in terms of the cross section, let's look over here on the right side. What we're going to be seeing is the kind of middle members of the Grand Canyon supergroup rocks tilted. We'll be seeing the Great Unconformity, the boundary between these tilted rocks and the flat-lying Paleozoic rocks, and then we'll be seeing the full suite of the Paleozoic rocks from bottom to top. So let's have a look. Here we are at the Walhalla Viewpoint. We are looking generally towards the southeast. You can see some people over here at the actual viewpoint location. And what we see here in front of us and off to our left is the Paleozoic rock. So from this line up is the Paleozoic suite. This is the Tapete Sandstone, the Bright Angel Shale, the Muav Limestone is kind of hiding in here. Here's the Red Wall. On top of that is the Supai group. And on top of that is the Coconino Sandstone, and eventually up to the Kaibab Limestone, which you can see over here on our left. Similarly, off in the distance, everywhere above this line I'm drawing now, is the Paleozoic suite of rocks. Everywhere below that is the tilted Grand Canyon supergroup rocks, namely the Dox Formation. So let's zoom in and take a close look at this area. There's a couple of things to see here. So here we are. First, let's point out the difference between the rocks above this line and the rocks below. Okay, the line I'm drawing is the Great Unconformity. It is an erosional boundary between the tilted supergroup rocks. Notice these rocks are tilted off to our left, off to the east and northeast, versus the flat-lying Paleozoic rocks which sit on top of them. Right? So this is an unconformity. It's called the Great Unconformity. It's found throughout the Grand Canyon area. And in this area, the surface represents missing time of approximately a few 100 million years. It depends on where you are. In the western part of the canyon, the amount of missing time represented by this erosional surface here can be upwards of 1.2 billion years. Okay? It's a significant unconformity of different amounts of time depending on where you are in the park. In this area, because these are flat-lying Paleozoic rocks, and the dipping supergroup rocks below are dipping off to our east, we have an angular unconformity. In the western part of the park, the great unconformity, is a nonconformity. But here, because we have flat-lying Paleozoic sedimentary rocks over dipping rocks, it represents an angular unconformity. So these red rocks are the Docks Formation. There's a thick sequence of fine-grained sedimentary rocks deposited in shallow marine environment. The other thing I want to point out to you is this layer of black stuff. These rocks in here are the Cardanus basalt. This is a nearly 1,000-foot thick layer of lava erupted at the surface roughly 1.1 billion years ago. This occurred when North America was undergoing significant tectonic activity on its eastern and southeastern margin during the Greenville orogeny. And this area was thought to be a back arc basin, a part of the continent which was actually subsiding and undergoing minor amounts of extension. When you take a continent and extend it slightly, you often produce volcanic eruptions, and this Cardanus basalt, which you can see in other places too, is a result of extensive lava flow eruptions onto the surface. One last thing we can see here, this is the path of Unkar Creek, and it carries water and sediment and deposits it here down near the Colorado River into a roughly triangular shaped feature here called the Unkar Delta. And so the sediment moved by this creek is all deposited down by the Colorado River here and actually displaces the course of the Colorado River. It has to go around that sediment. So the Colorado River is hiding behind these rocks. And here it is right here. You can kind of see this white stuff is a little rapid. But the sediment deposited by the Unkar Creek forces the Colorado River around it. It makes a big curve to the left and then a big curve back to the right. And actually causes erosion of these docks, cliffs behind there. Right? It's an interesting example of how side creeks influence the course of the Colorado and therefore the shape of the Grand Canyon in general. Okay, let's move on to Cape Royal. Cape Royal is one of the greatest panoramic viewpoints in the park. This is a 360-degree image. You're going to be able to move it around when you're there and have a look at really what it looks like in all directions. So this is the view towards the southeast from Cape Royal. Again, we have the full Paleozoic sequence from this line upwards. This is the Tapeats Sandstone, Bright Angel Shale, Muab Limestone, Red Wall, Supai, Hermit, Coconino, Toro Weep is in there, and Kaibab Limestone. And off in the distance, again, we can see the dipping of the Cardanus basalt and the docks below also dipping off to our left, off to the east. Let's zoom in, closer look. So again, here's the Colorado River flowing to our right. We see the great unconformity, this surface here. So this is the Paleozoic rocks, Paleozoic sequence. And here we have the gently dipping at about 10 or 15 degrees of the Cardanus basalt and the Docks Formation below it. In front of us, we have a outcrop along this long ridge of the Supai group, Paleozoic Supai group, the Hermit Shale, and this is the Coconino Sandstone. The Toro Weep and Kaibab from this particular ridge has been eroded sometime in the past. One interesting feature of Cape Royal is this. It's a hole in the rocks. This is the uppermost layer. This is the Kaibab limestone, which has this little hole in it. Let's take a zoom and look at it. There's a viewpoint on top of that. You can drive fairly close and then walk out. You can see the people out there. And so this is a result of water, mainly. So rocks are exposed at the surface to rainwater, infiltrates, and it freezes during the winter and expands cracks, sort of like you can see one here. You can imagine this crack filling with water and expanding slightly when the water freezes in the winter and pushes that crack apart a little bit more. And that effectively breaks rocks over time, and in this case, formed a hole. This is called Angel's Window, and it's kind of fun. You can look through rocks to see the other rocks behind it. All right, let's go off to Cape Final. You can drive to Walhalla Viewpoint. You can drive to Cape Royal. You have to hike to Cape Final. It's a fairly easy hike. It's about 2 miles each way, relatively flat, and well worth it if you're ever in the area. Cape Final also offers some really spectacular 360-degree views, such as in this image, and some really great views of geology, especially looking towards the east, which is what we're seeing here. So here's the view from Cape Royal. In front of us is another long ridge of Paleozoic rocks. Just on the bottom here is the red wall. All of this is the Supai group. And right here is just a little bit of Hermit shale and a tiny bit of Coconino sandstone. The Toroweep and Kaibab have been eroded long ago. Behind it, we can see another example of the uppermost part of the Paleozoic rocks. This is red wall, up through the Kaibab limestone on the top. And below it, we can see a little bit of the Chuar rocks and the Chuar syncline. You can see this very gentle folding here of these of the Chuar member of the Grand Canyon supergroup. And if we go just around the corner and have another look, you can see a really great example of the Chuar syncline. So here's these gently folded sedimentary rocks of the Chuar group. Above that is the Tabit sandstone, and up through the Paleozoic sequence. One last thing here is there's a landslide block. So this is the red wall limestone. Notice how it kind of has some horizontal stripes to it, if you like, of light colored purple, kind of light colored purple again. And there's another piece down here that from somewhere above, probably somewhere here at some point in the past, slid down. This is a very large piece of rock. This is not a small thing. It's a very big piece of rock, but this is a landslide block of red wall limestone, which used to be somewhere up there. All right, thanks for watching. Go and take a look at the images for yourself, and I will see you soon.